Unit 8, problem post number 4, multiplying polynomials with application. Be sure to fill out your pre-score number 1 through 5, assessing your ability to multiply polynomials with application before watching this video. This video's guest of honor will be a wolf. So the wolf will do math. That'd be scary, right, if wolves could do math? But we'll teach him anyway. Okay, number 1, we need to simplify this expression. We have some constants to distribute into these groups of parentheses, then we can combine like terms. So I'll start with the one on the left, 2 times 3x squared. I will multiply the numbers like normal. 2 times 3 is 6, and there's no variable term here, so the x squared will just stay x squared and come down. 2 times 2x will give me a 4x, and 2 times a negative 6 will be a negative 12. Distributing this 4, I'm going to keep this negative in mind, so I'll actually be distributing a negative 4. Negative 4 times 5 is negative 20. The x squared will come down with it. Negative 4 times a negative 3x will be a positive 12x. And we have another negative times a negative, which will make a positive. 4 times 1 is 4. Now it's time to combine like terms, starting with my x squared terms. Remember, when combining like terms, when we circle our terms, we want to keep the sign in front of it, so I know, okay, this is a negative 20x squared combined with a positive 6x squared. That will make a negative 14x squared. The x terms, 4x and 12x, will combine to a 16x. And we have a negative 12 and a positive 4 that will combine to a negative 8. And there's the final answer. Moving on to number 2, we want the product of 2x plus 2 and this trinomial x squared plus 3x minus 7. Remember, product means multiplication, so I'm going to multiply the binomial by the trinomial. When I'm multiplying a binomial by a trinomial, I need to use the distributive property and multiply everything in this first group of parentheses by everything in the second group of parentheses. So we'll start with the 2x. 2x times x squared, I'll multiply the numbers. 2 times 1 is 2. X times x squared is x to the third. If I do not see an exponent, I know the exponent is 1, and I will add these exponents. 1 plus 2 is 3. 2x times 3x. 2 times 3 is 6. X times x will be x squared, again adding the exponents. 2 times negative 7 will be a negative 14, and the x will come along with it. Now it's time for the 2. 2 times x squared will be a 2x squared. 2 times 3x will be a 6x. And 2 times negative 7 will be negative 14. Combining like terms, starting with the highest order, 2x to the third. Nothing else is to the third power, so that will stay 2x to the third. Follow it up with the x squared terms. We have a positive 6x squared and a positive 2x squared. That will make a positive 8x squared. X terms, negative 14x and positive 6x will combine to a negative 8x. And the constant negative 14 is all by itself. Nothing to combine with it, so it'll stay minus 14. And there's the final answer. In number 3, we want to write this expression in standard form. So I've rewritten it here. We need to distribute this negative 2x squared first. We need to multiply before we do any addition or subtraction. So we'll distribute this 2x squared, keeping in mind we have a negative right here. So it's actually a negative 2x squared. So negative 2x squared times x. Negative 2 times 1 is a negative 2. First I'll drop the 3x. And then x squared times x will be x to the third power, adding the exponents. Negative 2x squared times 5 will be a negative 10x squared. And then this negative 4x will come down. Combining like terms, we have negative 2x to the third power as the highest order, nothing to combine with that. Following it up with negative 10x squared, but no other squared terms, so that will stay minus 10x to the second. Then the x terms, negative 4x and positive 3x. Negative 4 plus 3 is negative 1, but I don't need to write the 1 because I just have an x term, so I'll just say minus x. In number 4, we need to subtract 6x squared from x minus 4 quantity squared. When we are subtracting one quantity from another, it's important to just take a moment and think about which one should come first and which one should come second. In this case, whatever I'm subtracting comes second. So it says I'm subtracting this 6x squared from the x minus 4 squared. So I have x minus 4 squared, and I'm going to subtract the 6x squared from it. So I need to first multiply the x minus 4 by x minus 4. It's got to get multiplied by itself because that's what squared means. Then once that's all said and done, I can then subtract the 6x squared. So I will take a step to just write x minus 4 next to itself. And I'll also remember to bring down the 6x squared. Now I can use my distributive property and multiply everything in this group of parentheses by everything in this group of parentheses. X times x is x squared. X times negative 4 is a negative 4x. Negative 4 times x is another negative 4x. And negative 4 times negative 4, we have a negative times a negative, which makes a positive. And 4 times 4 is 16. And I'll have my minus 6x squared. I have some like terms to combine, negative 6x squared and a positive 1x squared. That will combine to a negative 5x squared. The x terms, negative 4x and negative 4x, will make negative 8x. And the constant 16 has nothing to combine with, so it'll just stay plus 16, and there is the final answer. Alright, well, time to do some substitution. In this next problem, we have expressions for a and b, and we want to find 2 times the difference of a and b. And we want to make sure we write it in standard form, meaning descending order, no parentheses. So I'll first start out by substituting the a expression for a, and then the b expression for b. So my expression for a is x squared plus 2x minus 3. Now I need to subtract the b expression, and when I do that, I need to subtract this entire quantity. So I actually need to introduce a new set of parentheses containing the expression equal to b. So I'm sure I have 2 parenthesis marks on the end here. This is the one grouping marking just b, and then the parentheses containing the quantity a minus b. I'll simplify what's in parentheses first by distributing this negative to change these signs. Then once I combine like terms, I'll distribute this too. So I'll keep the 2 right where it's at right now. Now I can distribute these parentheses. I'm going to change all of these signs. So I'll have minus x squared. Negative times negative is positive, so plus x, and negative times positive is negative, so minus 7. So now I only have the one set of parentheses. It's just this quantity, a minus b. Can combine like terms from here. I have an x squared and a negative x squared. These will actually cancel out and become 0. If I didn't have anything else, I'd have to keep that as a 0, but I have some other stuff that will combine to non-zero values, so I don't need to write anything for the x squared terms. Moving on to the x terms, I have a positive 2x and a positive 1x, which makes it 3x. And the constants negative 3 and negative 7 make negative 10. Time to distribute the 2. 2 times 3x will be 6x, and 2 times negative 10 will be a negative 20. And there's my final answer. Number 6, we have a word problem with a rectangular box that we need to find the volume of in standard form. So they give us the length, the width, and the height. I have them written over here off to the side. And we also know our volume formula for a rectangular box is length times width times height. So I'm going to need to find the product of these three quantities. So just a little substitution is in order. I'll plug in the x squared for the length. I'll plug in the 2x plus 3 for the width. And lastly, substitute x squared minus x for h. When I distribute, I just need to multiply the x squared by the first grouping of parentheses, and then I want to multiply that result by x squared minus x. So I'll distribute the x squared into the first set. X squared times 2x will be 2x to the third. Adding the exponents, 2 plus 1 gives me the 3. X squared times 3 will be a 3x squared. I'm going to make sure I contain this quantity in parentheses. It still groups together. I just distributed the x squared into this group. It's still being multiplied by the quantity x squared minus x. So when I use my distributive property again for these two, I'm going to make sure I multiply everything in this group of parentheses by everything in this second group of parentheses. I'll start with my 2x to the third, multiply that by x squared, will yield 2x to the fifth because 3 plus 2 is 5. 2x to the third times a negative x will give me a negative 2x to the fourth. This has an exponent of 1. Now it's time for 3x squared to be distributed. 3x squared times x squared will give me a 3x to the fourth. And 3x squared times negative x will be minus 3x to the third. Give this a once over, finding some like terms. We have a negative 2x to the fourth and a positive 3x to the fourth. 3 minus 2 is 1, so those terms will combine to a 1x to the fourth. I don't really need to write that 1 though, so I'm just going to say plus x to the fourth, and then minus 3x to the third. So there's the final answer, 2x to the fifth plus x to the fourth minus 3x to the third. That's our volume. Don't forget to fill out a post score, number 1 through 5, assessing your ability to multiply polynomials with application after watching the video.